Welcome to Creative Mathematics and Coding with CodeWorld. You're at Unit 1, Lesson 2, Part 1, Values and Equations. In the last lesson, you started to dig around with code and designed your own computer program to draw a name tag. In this lesson, we'll dig a little bit deeper and understand some of the basic ideas you're working with when you write your code. One of the most important ideas you'll use in coding is that of a value, and value is just a word that means a piece of information. You're pretty familiar with values already, even if you don't realize it, because one type of value is a number, and your school mathematics has been all about understanding numbers, performing operations on them, and using them to solve problems. But in CodeWorld, you'll go beyond numbers and talk about other types of values, including colors, pictures, text, and even entire computer programs. You'll start to apply some of the same ideas and tools that you've used to work with numbers to these other types as well. And one of the most important ideas or tools is an equation. An equation is just a statement that two values are the same or equal to each other. Here's an equation you might see from mathematics. 2 plus 7 plus 5 equals 14. This is a true statement because the number described on the left, 2 plus 7 plus 5, is the same as the number described on the right, 14. Let's get one thing straight though. You might think 2 plus 7 plus 5 is a math problem or a question that needs to be answered. Your computer, though, doesn't think so. To the computer, 14 and 2 plus 7 plus 5 are just different ways of describing the same number, and it doesn't really care which one you use. Just like you can write equations with numbers, you can write them with pictures as well. But there's one difference. Operations like addition and multiplication only make sense for numbers. So when we look at pictures, we need a new operation, and that operation is the and sign. If you like, you can think of the and as meaning on top of. So this equation just says that a red triangle on top of a yellow circle on top of a green square is the same picture as the one shown on the right. This on top of operation lets you stack pictures together, just as if they were drawn on transparencies or clear plastic sheets, and then lined up in a stack. This and, or on top of, operation is one that you'll use all the time in CodeWorld to break apart complicated pictures into their simpler parts. You have to be careful, though, to use operations only on the type of values for which they make sense. Last time you built a program to draw a CodeWorld logo, and a second program to draw a name tag. Suppose you wanted a program to draw both. You might try something like this. Program equals drawing of name tag and drawing of CodeWorld logo. But do you see the problem here? Remember that drawing of was a function for turning name tags into computer programs. But the and sign or on top of operator only works on pictures, not on computer programs. So if you wrote this code and tried to run it, you would see an error message, this one right here. This is just the computer telling you that this AND operator expected to be used with pictures, and it found programs instead. So how can you fix this? Simple. Just move the AND sign to the argument of the drawing of function, which is a picture. That looks something like this. Here's another example. Suppose you defined your name tag like this. What's the problem? Well, the plus sign or addition only makes sense with numbers. Here, you're trying to add two pictures. If you write this program, you'll see this error message, telling you that the plus operator expects numbers, but found pictures instead. So how would you solve this? Well, the mistake was to use plus instead of the and or on top of operator to combine your pictures together. Get it? Equations are a useful tool because they let us understand the relationships between different values. Suppose I asked you to fill in this dotted square to make this equation true. Take a few seconds to think and then write your answer down. Well, one answer you might have given was 8, like this: 7 plus 8 equals 15, and that's true. But that's not the only correct answer. You might have also said 3 plus 5. 7 plus 3 plus 5 is also an expression that has the same value or is equal to 15. We can do the same thing with shapes. What shape belongs in this dotted square to make this equation true? Once again, there's more than one correct answer. You might have written something like this. This is a true equation. If you stack the first picture on top of the second, it does leave you with the third. But it would be just as true to write this equation. It might seem silly since the second picture is already the one we're looking for, but it's still true that if you stack that first picture on top of the second, you'll get the same picture as the right-hand side of the equation. Since the expressions on both sides of the equation are the same, this equation is true. Here's a different kind of question we could ask. Can you fill in the 2 dotted squares to make this equation true? Again, take a second to think and decide on your answer. Once again, there's more than one way to answer this question. You might have written 8 equals 3 plus 5. You might have written 8 equals 1 plus 7. You might have even said 8 equals 2.5 plus 5.5. There are many different ways to break down numbers into pieces. In the same way, we can break down pictures in many different ways. How could you fill in these 2 boxes to make this equation true? Take a second to think and write down your answer. One way you might have done it is to break down that picture into a vertical line and a horizontal line. Another way you might have done it is to break it down into a top right corner and a bottom left corner. But these are not the only 2 answers. There are many different answers you could give as long as the picture on the left of the equal sign is the same as the picture described on the right. All right, now it's your turn. How many different equations can you write breaking down this picture into parts? Take your time and see how many unique ways you can find to break this picture down. See you next time.